Welcome to the Merlin and Metro News Network. Today's program will cover the engine indicating systems. These systems are unique because most of their sources originate with power plant systems, but they are displayed in the cockpit through airframe systems. In general, the power plant systems create the signal, and the airframe systems condition or modify the signal. This sometimes leads to troubleshooting problems in determining which part of the system is at fault. Now let's roll our first program.
The power plant indicating systems are necessary to safely and efficiently operate and control the engine. In summary, these indications are as follows. The exhaust gas temperature, or EGT system, is used to indicate the temperature within the engine. Because the point at which these gases are measured is not the most critical temperature point in the engine, an additional computer system is used to evaluate the signal. This system will be more fully explained later in the program. Engine torque measures the amount of power the engine is actually providing to the propeller. This is measured in percent, as read on the torque indicator. Two separate systems are installed. One measures the amount of positive power, or positive torque, the engine is producing to drive the propeller, and displays it on the torque indicator. The second system measures negative torque, or torque produced by a windmilling propeller driving the engine, as a means to determine engine failure and effect appropriate action. Engine RPM measures the speed at which the engine is turning. Remember, this is a fixed shaft engine, so there is only one indication and measurement of engine speed. There is no separate measurement of propeller speed. The speed is measured and displayed in percent. The amount of fuel actually being used by the engine is measured through the fuel flow system, which is displayed by the indicator in pounds per hour. A secondary instrument called a totalizer displays the total fuel consumed by both engines. A fuel pressure system measures the pressure being delivered to the engine-driven fuel pump. An oil status gauge contains a needle to display the oil pressure being produced within the engine, while a second needle is used to measure the temperature of the oil as it enters the engine. There are, of course, one of these gauges for each engine. There is also a single fuel pressure indicator with twin needles that reflects the pressure present at the fuel filter element. Each of these measurement systems is augmented through the use of warning and status lights. There are also other subsystems that operate in conjunction with the indicating systems, engine temp limiting being one of them. The exhaust gas temperature, or EGT system, provides the indications necessary for the pilot to maintain the temperatures within safe operating levels. The critical operating temperature actually occurs within the engine itself. The thermocouple temperature probes used as temperature sensors are actually located in the exhaust pipe, hence the name exhaust gas temperature. The temperature of the gases exiting the tailpipe is influenced by other factors and does not always reflect how close the engine is to its maximum temperature limit. Airspeed, altitude, and ambient air temperature all affect the exhaust gas temperature. Each of these factors must be taken into account in order to determine how close to the maximum temp limit the engine actually is. This can be accomplished through various charts and graphs, and by plotting in the necessary corrections. The result will be a red line limit that must be respected in order to ensure the safety of the engine. The problem is that this limit will continue to change. If the aircraft airspeed increases or decreases, the limit will change. If the aircraft's altitude increases or decreases, the limit will change. If the temperature of the air the aircraft is flying through changes, so will the red line limit. The single red line, or SRL system, is installed to overcome these problems. An SRL computer is fed the necessary information and will provide an adjusted signal to the temperature indicator. This signal has been manipulated so that the pilot has only one red line number that must be observed, even though the actual temperature limit may change. Because the temperature limit can and does change, the possibility of exceeding it before the pilot has time to notice it and react was also considered in the design of the SRL system. A separate temp limiter subsystem has been installed to prevent such occurrences. The temp limiter can automatically reduce the fuel supply to the engine to keep the temperature within limits. A blue indicator light is installed for each engine to inform the pilot that the temp limiter circuit is reducing the fuel flow to the engine. The major components of the SRL system are the thermocouples installed in the engine exhaust pipe. These units produce a very small electrical signal that corresponds directly to the amount of heat being produced. Generally, the hotter they are, the greater the signal they produce. The signal from the thermocouples is supplied to a unit called an EGT compensator. Like all mechanical things, each engine is slightly different. These differences mean that each engine will produce its full rated power at a slightly different internal temperature. If this difference were not accounted for, each engine installed on the aircraft would have a different redline limit. The EGT compensator is selected and installed by the engine manufacturer during time of engine test to ensure that all engines will provide an equivalent reading at equivalent power outputs. The amount of compensation required is selected carefully and is usually unique to a given engine. The now corrected signal from the EGT compensator is routed to the SRL computer located on the aft equipment rack. The wiring used to carry this signal is a special type of conductor designed specifically to transmit thermocouple signals. As such, several cautions are in order. First, the wire cannot be cut and spliced. To do so will seriously degrade the accuracy of the indication and quite possibly lead to engine damage. Even connections at the cannon plugs must be made in accordance with special instructions in the maintenance manual. Precise limits are provided for the resistance that must be present in this cable. The SRL computer now has the temperature information provided by the thermocouples. But to correct this information and display a single red line to the pilot requires additional information. One of the bits of information required is the RPM of the engine. Instead of using the same RPM signal used by the tach indicator, a separate signal is used, which in essence prevents double failure of the SRL and tach indicator system. This signal is obtained through a pickup located on the prop governor, called the prop governor monopole. Another required bit of information is the air density. This is obtained by routing pressures obtained at two different points in the engine to a device called the delta P over P transducer. This unit will provide an electrical signal for use by the SRL computer, which is derived from a determination of the airspeed of the aircraft and ambient pressure. The air sources supplied to the delta P over P transducer are referred to as P2 and P5 pressures. The last source of information supplied to the computer is a temperature measurement of the inlet air temperature. This is accomplished through the use of a temperature probe that extends into the engine inlet, referred to as the T2 sensor. Using these sources, the SRL computer will produce a signal to drive the EGT indicator in the cockpit that will always be correct. Before being fed to the indicator, the signal is passed through a component called the temp limiter. This unit controls the fuel limiter bypass valve located on each engine. When the temp limiter sees the engine temp begin to exceed the preset limits, it will begin opening the bypass valve to reduce engine temperature. A temp limiter bypass light will be illuminated when this occurs. These lights are driven by an SRL and fuel bypass interface box located on the aft equipment rack. The system also senses when the water injection system is operating and automatically compensates the EGT limit to recognize this occurrence. The operation of the AWI system is sensed through a pressure switch installed in the AWI manifold itself. While not directly related to the EGT system, the SRL computer also contains the speed switch circuitry used during engine start. The speed switch select switches on the left console connect directly to their respective SRL computer. Also located on the left-hand console are the temp limiter test switches, as well as switches to control power to the SRL and delta P over P transducer.
Of all the engine indicating systems, EGT is easily the most important. Under most ambient conditions, the engine will be operated near the EGT limit during engine start and most takeoffs. And it doesn't take much operation beyond the EGT limit to seriously damage the engine. One of the most frequent sources of incorrect EGT indications is caused by cutting or splicing of the special EGT leads. The information in the maintenance manual concerning these items must be absolutely followed if the EGT indication is to be accurate. Now let's return to our program.
The engine torque system provides the pilot with an indication of the actual power being produced by the engine. The primary components are units or sensors within the engine called strain gauges, the torque signal conditioner, and the torque indicator. The key to the operation of the system is a strain gauge measuring system within the engine. While we will not go into the details of how the strain gauges themselves work, suffice to say that the electrical output through the strain gauge system will vary in relation to the strain placed on selected engine internal components. This strain equates directly to the amount of power being supplied to the propeller by the engine. As this power level changes, so will the output of the strain gauge system. The electrical output of these strain gauges is very small, in the millivolt range. A signal conditioner box is used to supply the strain gauges with a very carefully regulated source of electrical power, and to precisely amplify the strain gauge output signal for use by the torque indicator. Because of manufacturing differences between engines, the strain gauge output is not always identical. These differences are carefully determined at the time of engine buildup and test, and are compensated for by adjustments to the torque signal conditioner box. There are two identical sets of strain gauges located within the engine. The second set is a backup for the first, should a malfunction occur that could not be repaired without engine disassembly. The RPM system consists of an engine-driven tach generator and an indicator in the cockpit. The tach generator is actually a small AC generator, and the indicator a small AC motor. The output of the tach generator and the response of the motor within the indicator have been carefully matched so that the indicator will be driven to accurately reflect engine speed. The fuel flow indicator shows the actual amount of fuel being consumed by the engine. The system consists of an indicator for each engine, a fuel consumed counter, which reflects the total fuel used by both engines, a fuel flow signal conditioner box, and a fuel flow transmitter for each engine. The transmitters are actually small turbines that are driven by the passage of fuel through them. The more fuel flowing through the transmitter, the faster it spins. As it spins, it produces a small series of magnetic pulses that are fed to the fuel flow indicator. The transmitter also contains a temperature measuring unit as well, which is also connected to the indicator. To ensure accuracy of both the fuel flow indication and the amount of fuel consumed, the temperature of the fuel must be taken into account. Each fuel flow indicator is also connected to the totalizer signal conditioner box. This unit totals the fuel flow from both engines and provides the pilot with an indication of the total fuel consumed in pounds. Since many performance aspects of the aircraft are based on weight, it is important to the pilot to know the actual amount of fuel consumed. The oil system gauges provide an indication of the oil pressure and temperature for each engine. Oil temperature is read through a temperature-sensitive resistance bulb installed on the engine near the main oil supply line hose. Oil pressure indications are provided through a sending unit. This unit is located aft of the firewall on earlier model aircraft and forward of the firewall on the left-hand side of the engine on later model aircraft. There is also an oil pressure warning switch that will cause the annunciator panel red oil pressure warning light to illuminate when the pressure is below the acceptable limits. This unit is also mounted aft of the firewall on earlier aircraft and forward of the firewall on later models. The fuel pressure system is used to indicate the pressure at the fuel filter element. This is referred to as an interstage pressure because it is upstream of the engine-driven high-pressure pump and does not reflect the increase that will occur at that point. A dual needle gauge is provided to display the pressure indications.
Well, that does it for the power plant indicating systems. The engine itself is easily the most expensive component installed on the aircraft. The importance of the power plant indicating systems to the safe operation of the engine cannot be overstressed. Until our next program, good flying and good maintenance.